Okay, hello everyone. In the new video, so we have reached part 4 of chapters 5 and 6 related to the forces, mechanical actions, and weight. So now in this one, we are going to solve some exercises. Let me start by exercise number 7, page 101. So they are telling me tension of a string. A string OA is vertically suspended by its upper end, O from a horizontal support, and carries at its lower end A solid S as shown in figure 1. So they mentioned figure 1, so we will refer to this figure. Notice that they didn't mention anything about figure 2, then we are not allowed to use it. So for the time being, let's ignore this one, okay, since we are only talking about the figure 1. Now this is the string is a rope, and this is the solid S, okay. So now in 7.1 they are telling us the solid is subjected to two forces, its weight W and the tension T. Now the solid is subjected to the weight because it simply has a mass, and it's subjected to the tension because we have a string. So whenever we have a string, then the tension will exist, and they are telling us that each of these forces has a magnitude of 3 newtons. Now in part A, they are telling me indicate for each of these forces whether it's a contact force or an action at a distance force. We know that the only 3 forces that act at a distance are given by the weight, the electric, and the magnetic. All other forces are classified as contact forces. So let me say that the weight W is action at a distance, and all other forces are classified as contact forces, and in particular the tension T. Now in part B, they are telling me specify the characteristics of W and T. The characteristics are given by the Bildum. Let's start by the weight W. Then we have the point of application, line of action, the direction, and the magnitude. So we always know for the weight, the first 3 properties are always fixed. The first one is given by the center of gravity G. And the second one is given by vertical, and this is downward because we know that always the weight, which is the gravity, acts vertically downward. Now as for the magnitude, the magnitude changes from one object to the other, depends on the problem itself. It's usually calculated using the formula W is equal to M multiplied by G, but here the calculation has been done for us and the value is given by 3 newtons. This is it for the weight W. Now as for the tension T, so first let me write the Bildum. And now let's complete these. Now because the tension T is a contact force, then the point of application will be the point of contact, and it is always along the string as for the line of action. Now let's complete these empty boxes that are here. So always for the tension T, these are always fixed. Now the point of contact between the string and the solid S is given by the point A. So the point of contact, which means the point that connects the string with the solid. Now along the string, this is the string, so notice that the string in this case is vertical. As for the direction, if the weight is acting vertically downward like this, and we know it is not falling, so the tension must oppose the action of the weight, and must be vertical upward. And as for the magnitude, they told me that the magnitude must be given by 3 newtons. Now in part C, they are telling me represent these two forces using the scale 1 centimeter 5 corresponds to 1.5 newtons, and represent means that we need to draw. So we are asked to draw these two forces that are given by the tension and the weight. In order to draw these two forces, we need to determine the length of each, and this is done by the connection between the length and the magnitude, which is the scale. Knowing that each 1 centimeters corresponds to 1.5 newtons, then 3 newtons corresponds to how much? We always place newtons under newtons, then we crisscross, then 3 multiplied by 1 divided by 1.5, this is equal to 2. Since this is under centimeters, then its unit is given by centimeters. So the length of the weight, which is the length of equal to the length of t, will be equal to 2 centimeters. Now in this case we need to reproduce the figure, but what is important only to reproduce the solid ass. So this is the solid ass. This is the point G, this is the point A. So the weight acts from the point G vertically downward like this. The length of W is given by 2 centimeters, worth 3 newtons according to this scale. And notice that we have represented W by respecting its properties. Now as for the tension T, from the point A vertically upward like this, so I have represented the tension T respecting these properties. The point of application is A, along the string vertical upward with the 3 newtons. 3 newtons is being respected because its length is given by 2 centimeters according to this scale. So this is it for part C, which is the representation. Now in 7.2, they are telling me a bar magnet is drawn closer to us and attracts it with the force F. The solid stops in the position shown in figure 2. They mention figure 2, now we can use it. So here what's happening, previously is the solid S being connected to A and the string is vertical. Now knowing that the solid S, for example, it is iron, now it is being attracted by a magnet. So now S shifts horizontally to the left. Now the force F is due to the magnet. They are telling me what do we call F. So here it is a bit tricky. So one might think that here they are asking about the contact force or action at a distance, but if we take a look on part B, they are asking me whether it's a contact force or action at a distance. So in this case they are asking me about the name of F. Since it is coming from the magnet, then its name is given by the magnetic force. Now in part B, they are asking me whether it's a contact force or action at a distance. We know that the only 3 forces that act at a distance are given by the weight, the electric, the magnetic, and F in this case is one of them, so it is an action at a distance. As for part C, specify the line of action and direction of F. Now in this case, I will represent F here in a small sketch in order to determine the line of action and the direction. So always in order to know the direction of F, Let's consider the center of gravity of the magnet. So this is the G of the magnet. Let's say this is G1. Now let's connect G1 and the G like this. So the magnetic force will be along this dotted line, which is like this. So this is F. Okay. So always, in order to determine the line of action and the direction of F, consider the center of gravity of the magnet. Connect both centers of gravity, and F will be along this line of action. So in this case, it's obvious that the line of action of F is horizontal and the direction is to the right, to the left. So the line of action is horizontal, the direction is to the left. Now in part D, they are telling me represent F at point G without using a scale. So, and by represent, it means that we need to draw. Since they are telling me without using a scale, which means that the length of this vector is not important. So this is the solid S. This is the point G, because they are telling me represent at point G. So in this case, this is F horizontally to the left, and in this case, the length of F is not important. For this reason, I didn't specify neither the length nor the magnitude. So this is it for exercise 7. Let's move to the next exercise, which is exercise number 8. Tension of a spring. Page 102. They are telling me a spring is vertically suspended from its upper end O from a horizontal support and carries at its lower end a solid S as shown in figure 1. So they are talking about figure 1, now we can use it. Notice that they didn't mention anything about figure 2, then we will ignore it for the time being. In 8.1, they are telling me solid S is subjected to two forces, its weight W with a value of 6 newtons, and the tension of the spring T with a value of 6 newtons. Here, the value corresponds for the magnitude. So the magnitude is given by 6 newtons for each of the weight and the tension. So already they gave me one of the properties for each force. Now in part A, they are telling me indicate for each of these two forces whether it's a contact force or action at a distance. We know that the only three forces that act at a distance are given by the weight, the electric, the magnetic. All other forces are classified as contact forces. So let me write here that W is action at a distance, and all other forces are contact forces, and in particular the tension T. Now in part B, they are telling me specify the characteristics of W and T. So the characteristics means the properties. Let me start by the weight W. So we have the point of application, line of action, notice that I always list them in the Pilldom order. So gravity acting on the solid S to pull it vertically downward. So always the first three properties will not change. Center of gravity, G, vertical, downward. So these three, they will never change. Now what will change is only the magnitude. In this case, the magnitude is given by 6 newtons. So let me write here 6 newtons. Okay. Now as for the tension T, point of application, direction, line of action, Knowing that the tension T is a contact force, so the point of application will always be the point of contact. And as a fixed property, the line of action will be always along the string. But here, since we are talking about a spring, so let it be a spring. Now in this case, the point of contact, which is the point that joins the two bodies that are at interaction, is named by the point A. So let me say the point of contact A. Now along the spring, notice that the spring is given by vertical. So we don't care about this part that is tilted like this. We only just care about the part connecting the spring and the solid S. So notice that this part is vertical. The direction, in this case, if weight is acting vertically downward, the direction of T mass opposes the action of the weight, so this is upward. And as for the magnitude, it is given to be 60 newtons. So this is it for part B. Now in part C, they are telling me represent these two forces using the scale, and by represent it means that we need to draw. So in order to draw the vectors, we know that our rulers are graduated by centimeters and not by newtons. So knowing that each 1 centimeter corresponds to the newtons, what about 60 newtons corresponding to the magnitude of these forces? 6 multiplied by 1 divided by 2 is equal to 3 centimeters. This is 3 centimeters because under centimeters, 6 multiplied by 1 divided by 2. Then the length of the weight and the length of the tension is given by 3 centimeters because it's given by 60 newtons. So now this is the figure S, the solid S, redrawn here. This is the point A, this is the point G. And now we need to represent the forces, the weight, and the tension. So this is the weight, taking into consideration that the weight is vertically downward at the point G, 3 centimeters. So this is 1, 2, for example. Now these lines, just to indicate that the length of this vector is 3 centimeters, the name of this vector is W, and it is worth 60 newtons according to this scale. Now as for the tension T, we draw the tension T from the point A because the point of application is A, vertically upward. The name of this vector is the tension T. It's worth 3 centimeters given by 60 newtons according to this scale. So this is the representation of the forces. Now no need to redraw the spring because only what is important just to represent the solid S and what are the forces that are acting on the solid S. Now in 8.2, they are telling me a bar magnet is now placed under S on the vertical passing through G as shown in figure 2. So they mentioned figure 2. Now we can use it. It attracts S with the force F. So this is the force F due to the magnet acting on the solid S. They are telling me specify the line of action and the direction of F. So in order to specify the line of action and the direction of F, as we have said previously, so let's locate the center of gravity of the magnet. This is G1. So now this is the dotted line that connects G with the G1. So it's pulling it downward, so the line of action is vertical and the direction is downward. Then in this case, part A, line of action is vertical. Direction is downward. In part B, they are telling me represent F at point G without using a scale. Represent by itself, it means that we need to draw. We need to draw the force F on the solid S without using a scale, taking into consideration that it's acting vertically downward. Then this is the point G. this is vertically downward like this. So this is the fourth f. Notice that I didn't take into consideration the length of f because they are telling me without using a scale. Then this is it for this video, guys. And the next part we complete solving exercises on these chapters.